Hello, welcome back. Let's solve Leetcode 49 group anagrams. Okay, so given an array of strings, so group the anagrams together and we can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of different word or phrase, typically using all the original letters exactly one. So for example, this string arrays, we have three groups of anagram: BAT, NAT, and TAN is one group because TAN is if we rearrange TAN, we will receive NAT, and ATE, EAT, and GEA is another anagram groups because if we rearrange EAT, we will receive ATE, and similar as GEA, if we rearrange, we will receive ATE. Okay, so for this problem, the easiest way that we can think is we can try to sort uh, each string in ascending order, right? For example, with EAT, we will sort it at if we sort in the ascending order, it will becomes E A E T, right? And then for the second is also A E T, and for the third is A N T, the fourth is A E T, and the fifth is A N T, and the final one is A B T, right? And then after we sort each string in ascending order, we will need to have another for loop. We will loop for every string in the sorted after we sort it, and then we can easily find uh, the anagrams, right? Because if they are anagrams, so the string after sorted it, they must be equal each other, right? Okay, so if do that, so what is the time complexity? The time complexity in this case is out of n times m log m, right? Where n is the length of the given array and m is the length of each string, right? Because the cost to sort a string is O of m log m, and then we will do it n times, right? N times. Okay, so and then we will need another for loop to check if they are anagrams. So the exactly time complexity should be n plus n times m log m, but this is a constant, so we can eliminate. Okay, so that is the naive approach. Okay, so let's think if we have another better solution. Okay, so as we notice that each string will consist only lowercase English letters. Okay, so we can think about using an array, a static array of array of 26, the array has the size is 26 because from if for our case English it is starting from A to Z, right? So we will have an array has the size 26, and to map for each letter from A is 0, B is 1, C is 2, so on and so forth. Okay, and then we will check for each letter. We can build this array. For example, if ABC, right, if the string is ABC, okay, so then we can count, we can represent it as we can represent the array as 1 1 1 and 0 0 and then 0, right? We have 3 1 and 23 0, right? If we just only need to count the number of the corresponding letters that appears in the string. Okay, for example, if ABC, right, so it is 2 1 1, right? We will count the number of every single letters in the string, and then we will map them to the array of the length is 26, and then after that we will convert this array to a string. So for example, we will convert this array to a string is 2 1 1 0 0 0 with 23 zeros and 2 1 1 and 23 0. Okay, and then we will do the same, we will do same steps, we will do same actions for other strings, and then we notice that if they are anagrams, so this string must be equals, right? This string must be equal. So for example, if we have the anagram of AABC, maybe ACBA, so this is the anagram. It is one of anagram of AABC. So let's see, the array, right, is also 2 1 1 and 23 zeros, right? Because we will count, we have 2 A's, so as the first element in the array represents for A, it always 2, and similar with B and C. So the string is the string will be 2 1 1 and 23 zeros. It will equals for this string. So these two strings are anagram. It means exactly is they belong to the same group of anagram. Okay. Okay, so I think that's it. That's all for the idea for the optimal solution. Oh, okay. Let's check about the time complexity. Okay, and if do that, what is the time complexity? Okay, we will need to look through the whole array, and then we will need to look for every single string, for every single letter of any string to check, right? So the time complexity now is O of n times m only. Okay, where n is the length of the given array and m is the length of each string, but this time complexity will be better than the knife approach, which is sort every string, right? Okay, and then I think let's dive to the implementation. We will implement the optimal solution. Okay, but anyway, I think for this solution with this constraints is still acceptable solution, I think so. Uh, but okay, let's ignore for this solution. We will implement for the optimal solution, right? Okay, so notice that there is no S case for this problem. We only we don't need to check for any S case. Okay, we will declare a list of answer functional array list. Okay, and then we will declare an array has 26, that stands for the alphabet, right? New okay, so new in 26. And what we do next, we will loop for every single strings in the given array, right? So for string s in strs, and then what we do, we will loop through every single characters of the string s, char c in s.to char array. All right, and then we will count and update the alphabet c minus a plus plus, right? Okay, and after we do that, we will try to build a string key equal to string dot john empty string with alphabet, right? Okay, and then we can use this string as a key of a hash map of a hash map to prove every anagrams. Okay, so let's declare a hash map string list of string anagrams equal to new hash map, right? Okay, and what we do, we will need to get a list of string and okay, we call it as temp is equal to anagrams dot get or default key new array list. Okay, and then we will add s to the temp, and then put to the map anagrams dot put key and temp. Okay. And okay, when we repeat these steps again for another checking, we will need to reset the alphabet array, right? Array dot fill alphabet to 0, right? And okay, so after that we will have a list of we will have a hash map of anagrams, and for every values in the hash map, that is our answer. Okay, we will loop through the hash map and then add its as every value to the answer list. Okay, and for map.entry uh, map.entry string list of string entry is anagrams dot entry set. Okay, and then answer dot add entry dot get value. Okay, finally we will return the answer. Okay, so let's try. Compile error, no suitable method found. Okay, this method is not applicable for the array of integer. Okay, so that's fine. Let's write our own method. String array to string int array. Okay, string builder results new string builder, and then for int and from array rest dot append, and finally we will return rest dot to string. Okay, and this one will be array to string alphabet. Okay, try again. Okay, it looks good. Let's try to submit. Okay, we have wrong answer. Okay, why? Okay, the output is our output is in one list, but expected is two separate lists. Oh, okay. I think I know the reasons. Because when we count for every single characters, and we append the count alphabet array to the string. So if for example, for this case, right, we have for the letter D, it might appear more than 10, I mean more than 9 times, which will the numbers of counts will be greater than will be now it will be two numbers. And okay, so for this case I think we might need to append for another separator to the string to make sure they are not false into any edge case when we compare. Okay, so let's append an empty string. Okay, so let's try again. Okay, and submit. Okay, accept.